Gold bars, where do they come from? For aspiring entrepreneurs and investors in the gold business, understanding the full journey of gold is not only essential, but also full of opportunity. Let's start at the source. This is the world's largest underground gold mine. Every day, miners extract over 6,000 tons of ore from depths of 800 meters. Each ton contains only around 5 grams of gold. First, workers drill deep holes into the rock to place explosives, which blast the ore loose. The ore is then loaded onto transport vehicles and carried to the surface, where it enters a crushing plant. Here, powerful crushers break the ore into gravel-sized particles, which are further ground into fine powder by milling machines. A cyanide solution is added to turn the powder into a slurry. The slurry is pumped into large settling tanks, where heavy solids sink while the lighter liquid overflows to another tank. The solids are transferred to agitation tanks, where oxygen is injected to allow the cyanide to chemically bond with the gold and dissolve it into the liquid. The gold-bearing solution is separated using rotary filters, then zinc powder is added to precipitate the gold out, forming flakes that contain both zinc and gold. To refine these flakes into a gold bar, workers prepare a flux mixture using manganese dioxide, fluorides, quartz powder, borax, and sodium nitrate, which helps separate gold from impurities. The mixture is added to a furnace heated to 1,200 degrees Celsius. After 2.5 hours of rotation, heavy gold settles at the bottom while slag floats to the top. If any gold remains in the slag, it is remelted until none is lost. The molten gold is poured into bar-shaped molds and cooled in water for 1 hour. Once cooled, the gold bars are removed and cleaned. At this stage, the bars are typically only 80 to 90% pure, so further refining is required to reach the internationally recognized purity of 99.9% or higher. These crude bars are sent to professional refineries, which use advanced techniques like electrolytic refining or the aqua regia method. The first step is to melt the crude gold and form it into thin sheets. This increases the surface area and improves dissolution in aqua regia. However, these crude bars often contain base metals such as copper, iron, and zinc. These metals, while soluble in aqua regia, contaminate the gold solution and reduce recovery quality. Therefore, it's essential to pre-treat the material using dilute nitric or hydrochloric acid to remove base metals first. Silver poses another issue. It doesn't dissolve in aqua regia. Instead, it reacts with chloride ions to form silver chloride, a white solid that must be filtered out completely. If left unfiltered, silver chloride can clog pipes, reduce gold recovery, and lead to contamination of the final product. Fortunately, AgCl can be collected and later processed to recover pure silver. Once these impurities are removed, a reducing agent, typically sodium metabisulfite, is added to the gold-containing solution to precipitate pure gold powder. This is washed, dried, melted, and cast into gold ingots or granules. The resulting gold reaches a purity of 99.99%, suitable for international markets. After obtaining gold with 99.99% purity, how is it turned into market-ready gold bars? Currently, there are 2 main production methods: casting and minting, also called stamping or pressed ingots. Casting itself includes 2 approaches. The first is the traditional open mold casting method, where 99.99% pure gold from the refinery is melted in a furnace and then poured directly into open graphite molds to form and cool. While simple and cost-effective, this method presents several issues, such as porosity, oxidation, surface drag lines, bubbles, and uneven edges, which can negatively affect marking clarity and customer inspection. Additionally, casting losses can occur during pouring, leading to weight discrepancies and slight purity reduction. The second method is a more advanced vacuum casting process. In this method, gold is placed into a vacuum ingot casting machine, where it is melted and cast under vacuum and inert gas protection This sealed environment eliminates oxidation and weight loss and results in a flawless, mirror-like surface with no air bubbles. Each bar comes out uniform in weight and density, enabling standardized production and greatly reducing the need for rework. Once casting is complete, identification information must be marked on the gold bar, the factory or brand logo, gold fineness, weight, serial number, production date, and origin. Each bar has a unique serial number for traceability and authentication. The bars are placed into a hydraulic stamping machine to imprint this data clearly, followed by laser marking for the serial number. Final packaging is done only after purity is verified using an XRF gold analyzer at every critical step, ensuring the bar meets precise specifications. For minted bars, we offer more detailed video demonstrations. In summary, this method involves continuous casting of molten gold into flat sheets, followed by rolling to the desired thickness using a rolling mill. The sheets are then cut to shape, annealed in a furnace, polished, and finally stamped using a hydraulic press to produce clean, high-detail minted gold bars. Whichever method you choose, we provide complete equipment and technical solutions. If you'd like to learn more about gold production processes, please subscribe to my channel.